Hi guys, in this video I'm going to use an example to try and explain the method of using the chain rule and when we would need to use the chain rule. So here what we have is we have a function y equals a function of x. Now we use the chain rule when we can see that the function that we have can be expressed as like multiple constituent functions. Now what I mean by that is another way my teacher told me is the chain rule is used for when we have a function inside another function. Now whether that makes sense to you right now, I don't know. But what we can do with this is we can try and split this up before we even start looking at the chain rule into two different functions. Now the way I'm going to do that is I'm going to pull out this fifth power function and make it and substitute it out for basically one letter. So the standard sort of notation that we use here when we're pulling a function out and we're going to replace it with a letter is we're going to call it u. So here, u is going to equal 7x to the 5 plus 4x cubed plus 15. So what we can see is we've got a new function, u in terms of x. And what we can also do now is we can express, because we've pulled out that u, we can also express y not in terms of x, but we can express y in terms of u. So what we have here is we have our overall function can be made up of a cubic function, and then inside that cubic function we have a fifth power function. So the chain rule says, I'll stay with this colour. So the chain rule says that if we have, well, we're looking for a derivative of a function that looks like this. So if we're looking for dy dx, what we can do, this is going to equal the derivative of the outside function, which in our case is y in terms of u. So the derivative of y in terms of u multiplied by the inside function, which is u in terms of x. We're going to find the derivative of that as well, du dx. Now the reason I've written it in this notation is because this is why the chain rule works. The reason we can find the derivative of the entire function by taking the derivative of an outside function and inside function is because we have dy in terms of du and then du in terms of dx. The du's in this fractional multiplication cancel, giving us dy dx, as you can see on the left hand side of that equation. So that fundamentally is our chain rule. So let's get to solving this problem that we've been given. So what we need to do to start with is we need to find out what the derivatives of both of these are. So we have here the derivative of y in terms of x, so let's write that one down first. Dy, sorry, not in terms of x, in terms of u. And I'm assuming you know how to do basic derivatives here. So 9u cubed, the derivative, we times the 3 by the 9 and we get 27. We have the u, and we drop the power by 1. So we have 27u squared. Now we have to work out what the derivative of u is in terms of x. So this is going to be du dx. And this is going to equal times the 5 by the 7, and we'll get 35x. We're going to drop the power of the 5 by 1 to the 4, plus 3 times 4 is 12, x to the power of 3 take 1 is 2. And then the 15 drops off because it is a constant term. So here we have our dy du and our du dx. And the chain rule states, and this is just to make it super straightforward. So we have dy dx is equal to dy du times du dx. Now, we fill in our dy du, which is 27u squared. And we have to multiply it by du dx, which is, I'll put it in brackets, 35x to the 4 plus 12x squared. So here is basically how our formula is going to look at the end. But we're still one step away from finishing. Why is that? Because we want dy in terms of dx. So we're expecting a y in terms of x for our differential equation, but we have a u in here. And that's quite simple to fix. All we do then is we substitute the u that we initially pulled out back in. So what then happens is we get a final product, which is dy dx is equal to 27u, which we know is 7x to the 5 plus 4x cubed plus 15. I close the bracket. That's my u term. I then square it. So squaring it. And then I'm just going to multiply it by 35x to the 4 plus 12x squared. So there is our final answer to this differential. You could simplify it if you're trying to use some sort of graphical powered calculator to work out the differential. It wouldn't give it to you looking like this. It would be a lot more of a simplified version. But in an exam situation, you wouldn't be expected to simplify it any more than this, because the numbers, if you times the 27 into this bracket here, will just be too big to solve by hand in an appropriate amount of time. So that's the chain rule for you guys. I hope it was enlightening. Stay tuned, I guess. Thank you.